commentating their observations along with their discussion. They'll have 10 minutes for that warm-up discussion.
Houston integrity. We have two folks at the window deep in discussion talking about all of the awesome features that they're seeing. We just had a huge moment realizing that Hertzsprung is about the same size as our incredible Orientale. We're really excited about this target that's kind of new to us. We're orienting on things like how we talk about albedo, finding some of the prevalent things that we're used to from all of our training, and just overall taking in this view. We also are noticing that the moon is still getting noticeably bigger as we go, even when you're watching it continuously. It's great to see these two guys get warmed up.
We love the report, Christina, thanks. And you nailed it on why we added Hertzsprung. As you'll see in the prompts, we're looking for comparisons to the comparatively much older Hertzsprung compared to the younger Orientale. Great words.
This is Artemis Mission Control. That was the voice of Dr. Kelsey Young speaking with the astronauts aboard Orion as they begin their observation period and lunar flyby. NASA astronaut Christina Cook reporting their view of Hertzsprung Basin. The team here is looking for centered images of the basin at a full zoom, and they're hoping that the astronauts can image and describe the inner and outer rings. This is considered a degraded basin with a floor, rings, and ejecta compared to a younger Orientale basin. We spoke earlier with Julian Gross, the Artemis curation lead, about some of the terms we will hear the crew use today. One of those just called out, that's albedo, looking at surface brightness, or the amount of light a surface reflects. A few more terms that we hope to hear today during the crew's sit-reps or situation reports include embaying. This refers to one feature that surrounds another. That usually is a higher relief feature.
Houston integrity, one report from the crew at the windows. we can actually see the moon and Earth at the same time right now. It's interesting because the Earth looks way brighter, so the Earth itself seems to have a much higher albedo than the moon. We think this is independent of our eyes focusing because, of course, the Earth is much smaller than the moon in our view. So you could think that your eyes focus for the darker sky, and that it means that it only has apparent brightness more than the moon. But since we're seeing both in the same view, we do think that this can be inferred as the Earth as a whole has a higher albedo.
Great observation, Christina, and reminder that as you're starting to look for those subtle color and albedo variations on the moon, the relatively bright albedo Earth might make those a little bit difficult, but as your eyes continue to adjust, we expect you to start to see more nuance on the moon. Thanks.
Great call. Thanks for the reminder.
We're all going to be experts in lunar terminology by the end of the day. Another one we expect to hear is mare. These are dark regions paved or filled by volcanic deposits. You also can hear them called seas, oceans, lakes, or marshes, or other bodies of water. Again, we are live in Artemis Mission Control, but on the right side of your screen, that is the Science Evaluation Room, team members who have been preparing for this day for years. The crew has significantly darkened the cabin of Orion. This allows them better views outside the windows and fewer reflections from inside. They reported being able to see the moon and the Earth out the same window at this time. We are really hopeful to get those photos. Right now, this view on the left side of your screen coming from a camera mounted on one of the solar array wings on Orion outside the spacecraft. The crew is equipped with 80 to 400 millimeter zoom lenses. The team continues their warm-up discussion. I should say the crew members aboard Orion continue their warm-up discussion. However, they are about to be prompted to move on to discussion number 2, which is near side and far side. Some of the things that they are looking to capture, the ground has prompted them to photograph anything that stands out to them and to compare the near side versus the far side mare in color, albedo, topography, and texture. They also want the crew to compare the appearance of rayed craters in the near side mare versus in the far side highlands. Of course, a reminder that some of the items that the crew, or some of the landmarks the crew are seeing today, is the first time that humans have ever laid eyes on those portions of the moon. In the targeting package, there are a few reminders of the crew. For the crew, there are time-sensitive observation reminders and science sit rep reminders.
Integrity. We have a sit rep. The targets that are being discussed right now, it's the far side, near side comparison, and hearing some great discussion of browns and greens in the Aristarchus Plateau and how those disappear as you go toward the North Pole, and then over to the far side, you lose the color. You've got Jeremy in window 2, Reed in window 1, having a great discussion. Christina's under window, I'm sorry, Reed is in window 3. Christina's under window 1, documenting the discussion. And we've got the lights completely off in the cabin. There are some LEDs that we cannot put out that do provide some light scatter. But we have all of the internal lights off. And are letting our eyes adjust as best we can. The window 4 view, you only get about a third of the moon. Tycho is going to go over the horizon soon, and you can see Aristarchus, and then you start to lose the view as you go to the west in Oceanus and Procellarum. So far, the team is on the plan, and the long lens is being put to good use, and recordings are being made, and internal documentation of the configuration and the observations is ongoing. Science, do you have any questions for us at this time?
Integrity Science. Victor, very glad that you provided the first formal science sitrep, as these were indeed your idea. One follow-up question, any relationship between those browns and greens you described? Do you see them blending into one another, and do you see any topography associated with either color?
I don't want to bother the window team. I just heard that, overheard that, and so I'm sorry I don't have that detail yet. I will eavesdrop and see if I can pick that up. I will try to answer that at some point. I also heard a comparison of the albedo in Aristarchus, that crater, the very high albedo spot. You can see it on the near side. There is a feature called, I believe, Burgess alpha, that is equally or maybe higher albedo. I apologize for the gaps. I'm trying to listen and talk at the same time, but I will try to get some more information to correlate those colors from Aristarchus for you.
Understood, Victor, and good call to not bug the window team. Really like the brightness comparisons to Burgess A. Really helpful for the science team. Keep them coming. Thanks.
I also heard a discussion about the albedo of Grimaldi being a 10, and how many of us, when we were a little further away, saw that as the darkest albedo, and that the bigger Mare off to the to the east was still dark, but maybe a 7-8. We still think that, but you are seeing color variation, albedo variation inside of Grimaldi as well, and that even on the west side there's still a very dark part of it. But it is still the darkest. It is just not as uniform as it looked when we were farther away. We're starting to differentiate the striations of albedo inside of Grimaldi.
Copy all, Victor, and you read our mind. Superlatives like darkest, biggest are really, really helpful for us, so keep those coming.
As we were just mentioning, the crew is slated to perform these science sit reps. They are prompted to do so by an icon in their lunar targeting plan. That one coming down from NASA astronaut and pilot of Artemis II, Victor Glover. As we discussed, the Capcom is usually the only person in the room speaking with the crew, the capsule communicator. However, today, the science officer, Dr. Kelsey Young, she is the Artemis Science Flight Operations Lead, is speaking with the crew during the flyby to ask any questions that the team may have. To her right is Trevor Graff. He is one of 3 science officers. Those would be Kelsey Young, Trevor Graff, and Angela Garcia, who will also join us later for an interview.
And Houston Integrity Science Integrity was able to get a view out of window 1, which is a beautiful view. I can see the entire moon that they're looking at. We left the T-shirt up there, so I was kind of peeking through the opening in the makeshift shroud there. And once I was able to get 2 eyes on it, what jumped out at me was Vavilov. It's just peeking out of the Terminator. It's clear of the Terminator now, but it just really jumps out because it's still got the low light, the low sun angle. And so where the, Vavilov has that impact over the top of another crater, where the 2 craters intersect on the eastern edge. So on the side closest to Orientale, where the 2 crater rings intersect, the shadow there is the highest peak in the interior of Vavilov, and so you can see that terrain is, there's some real variation in the terrain there, that there's a nice peak where those peaks intersect, where those rings intersect, and we'll get a picture of that.
Love the description, Victor, especially the comparison and relationships you just described about topography. And if it's easier for your observations, do feel free to remove the T-shirt shroud from window 1.
Yeah, absolutely. We will do. Thank you.
Those calls coming from NASA astronaut Victor Glover. As we discussed, the crew is working in pairs at the windows. Right now, taking photos are Commander Reed Wiseman and Mission Specialist Jeremy Hansen. Serving as their support team are pilot Victor Glover and Mission Specialist Christina Cook. You're hearing those calls from Victor Glover as he is on that support team, and he is tasked with providing the science sit reps, while the 2 crew photographing and making annotations of the moon are in windows 2 and 3. Windows 1 and 4 are available for the support crew to fly up to, obviously look at the moon themselves, and provide these science situational reports. The view on your screen is part of the lunar targeting package, and it's something that the crew can reference as they are flying by, but this is an animation. You also heard Glover mention Orientale. Orientale is a major feature that the team is interested in today, and it's known as the Grand Canyon of the Moon. Until this mission, the Orientale Basin had never been seen in sunlight by human eyes. Orientale Basin and its surrounding ejecta could fit within a straight line distance from NASA's Johnson Space Center, where we are at today, to Kennedy Space Center. This a live view in Artemis Mission Control in Houston, Texas, where the teams are monitoring all systems, not just for today's flyby, but on the spacecraft themselves. Again, this is a test flight, our very first flight of humans on the Orion spacecraft. This team has been This team has been monitoring the entire time of the mission, as well as we have been live the entirety of the mission, and we will be continuing to do so all the way through splashdown and crew recovery from the Pacific. This is a visualization from ARROW, the Artemis Real-Time Orbit website that you can also access at any time by visiting nasa.gov/trackartemis, showing us that we are now under 10,000 miles from the moon, 9,948 to be specific, and continuing to count down. Again, our closest approach to the moon today should come about 6:02 p.m. Central, 7:02 p.m. Eastern. However, we will be out of contact with the crew at this time as they begin transiting behind the moon. At that time of closest approach, the distance from Orion to the lunar surface will be about 4,070 miles. Of course, these are estimates at this time, and we'll be sure to provide you with the official numbers once that closest approach has been reached. This shot live inside the Orion spacecraft, where our 4 crew members are continuing with their lunar flyby activities. They have just begun those activities really about 20 minutes ago, so we've got several hours of moon view opportunities. This is still a live view inside that capsule. However, you can see just how dark they have turned down the lights. Actually, they've turned them all the way off. There are a few LEDs that they cannot power off, but turning down these lights gives them better views outside of the spacecraft's windows while they photograph the moon. This also prevents any reflections from inside the spacecraft bouncing up on the windows and interfering with their photography. As we were previously discussing, the crew members are serving on teams, the first team being Commander Reed Wiseman and Mission Specialist Jeremy Hansen at the windows photographing what they see. We heard reports earlier that they could see both the moon and the Earth in the same view, and we are looking forward to seeing the moon and the Earth in the same view as well. That Earth set coming up in just a few hours. While Wiseman and Hansen are at the windows photographing, Glover and Cook are serving as support crew. They are able to assist with cameras. They are also providing those situation reports, letting us know how the team is working inside the spacecraft, what they're seeing, and how they're feeling about it. Those first blocks of teams will last about an hour, and the crew members are approaching the halfway point into their first observation block. A reminder, we have 5 of those blocks today. So they're approaching this halfway point, during which the crew at the window will switch roles. One will begin taking pictures, and the other will be making annotations on their PCD, that's portable computing device. Both of those crew members at the windows are recording audio of what they see. They are putting on headsets and recording audio into their portable computing devices. Obviously, we are not hearing this right now. This is going to be sent down to the science team, and they will be able to analyze that at a later time. What we are hearing, though, and will continue to hear, are those science sit reps a few times every block. Once this block is complete, about 40 minutes from now, we will have the teams switch. That means pilot Victor Glover and...
Science integrity, looking out of window 1. I think I may have misreported earlier saying that it was Tycho going over the horizon. That was Copernicus I was referring to. Apologies. It was Copernicus is what is farthest bounding to the east, and that is now like on the horizon or just past it. And the Korolev is now a few degrees from going over the horizon. And then, you know, next it'll be Aristarchus Plateau. And so on the west, we are getting a much better view of the Terminator. It looks like we have about 80% illumination of the moon. And Vavilov and one Vavilov diameter to the west is where the Terminator is right now. And so other features are starting to peek out there. The center of the illuminated part of the moon is to the lower part is Orientale, and just around Orientale, a lot of light structure is starting to show up. A lot of high albedo, similar to the feature, I cannot remember, Burgess Alpha and Aristarchus type high albedo in the ring. So when you look at the interior ring and the external ring, it's almost as if the edges are starting to dry up and turn white. If it was something that was wet and got dry, the edges would be the part to dry first. You just kind of outline all the topography in the interior of that wall is like it was dusted with chalk or is starting to dry, or maybe dusted with snow. If this was the Earth, I would say there was snow dumped on some of the ridges on the interior of the rings of Orientale. Also, an interesting part of the discussion that I heard between Reed and Jeremy is that from Glushko to Grimaldi, there are two dark features there that look like commas, but in the wrong direction. But there's also a lot of interestingness, just a lot of geometry and squiggles and dots and lines that are starting to stand out as more small features come into view. And there also is a lot of variation in albedo. In some of those, the two dark features, for example, have on the southern edge of the larger one, the one that's further to the south, there's a very dark, the one albedo, like the southern and western part of Grimaldi. And the one to the north, closer to Glushko, is also that same dark albedo. And then around them, there are some very high albedo spots just to the north of the southern one, and just to the west, the smaller one to the north. Very high albedo, almost approaching the 10, a 9 or a 10, like Aristarchus. And lots of little bright spots are just starting to pop up in this view. To the north, as you look up at the North Pole, there is a very distinct crater with a lot of very defined central peak that is also 3 in albedo, and all of that area past it, going to the horizon, gets lighter and lighter, and is very, very high albedo. And I will go look and find the name of that feature if I can look that up. And then to the south, really getting some interesting geography and topography in the South Pole Aitken Basin. And the view of the South Pole is quite amazing. We've got some Terminator there, as well as the limb view, and there is a very distinct crater right at the South Pole. And I'm going to go look up, I don't believe that is Aiken, but I'm going to go look up the name of that one because it's also giving a lot of good topography due to the shadows that I'm seeing. But that's, I was trying to bound the view that I'm seeing for you, and I got distracted by all of these interesting albedo variations that are popping up in the interior. But that's the view that we see. Just a Vavilov diameter to the west beyond is where the Terminator is. Just beyond, I think Copernicus is the easternmost feature that we can see. a very nice ringed, very nice structure crater to the north with a great high albedo central uplift to the north, and the south is dotted by a very characteristic crater with a lot of terrain, shadow features, and I will go try to find some landmarks to put names with those. Any questions for the observation team?
Integrity Science, love the descriptions. You're definitely looking odd up there. Appreciate seeing the training being implemented. Especially interested in your descriptions of the dark patches. You compared the comma-looking features to the albedo you see in Grimaldi and notice that you're starting to see those color differences popping out. Any observations you want to make, especially when you get on, the PCD in a little bit, would really help us tease out the differences in those dark Mare deposits. Great description, Victor. Keep them coming.
Absolutely will do, and I know you've got descriptions on both of the window observers right now as well. Keep them coming.
Great evidence of how well trained this crew is by the science team. NASA astronaut and pilot of the Artemis II mission, Victor Glover, calling down a situation report, noting several different features on the moon and such descriptions, even saying that it looks like snow on some of the peaks. Obviously, we do not expect that to be snow, but referencing that as some of the lighting on how it looks to the Artemis II crew from their current position. The team is slated to be switching their positions at the windows now. Both Reed Wiseman and Jeremy Hansen have been at windows 2 and 3, one taking photos, one making observations and annotations on their portable computing device. At this time, we also anticipate that they are looking at a crater duo. One of those is Glushko, and the other is Ohm. The team is looking to know the extent of Glushko's ray system and how its rays differ in the Mare versus the Highlands. They also want the team to compare the ray systems of Glushko to Ohm. Ohm is considered a young crater. And if you've ever seen a photo of the Richat structure, it's also known as the Eye of the Sahara. It's 40 kilometers in diameter, and that could fit within Ohm's interior. The team is specifically interested in descriptions of that ray visibility, including the color, albedo. Remember, albedo is the brightness or the surface reflection, and the reach. Again, I am using the same lunar targeting package that the crew is referencing on board right now. This helps keep them on time as well as prompt them for when they need to make a call down to the science team and report what they're saying. It also gives them reminders of when they need to swap positions at the windows. Additionally, I'm using the Artemis II Lunar Science Passport developed by Amber Turner and the Artemis II Lunar Science team. Now, this passport did not fly with the crew, but they used it extensively as a study guide here on Earth. So a lot of the descriptions and comparisons you hear today are developed directly by the science team. We are now 4 days, 20 hours, and 43 minutes.
Science, integrity, that crater to the north, that is we've got one in the north that looks like just a textbook crater, and one on the South Pole as well. The one on the north, I think, is Pythagoras. And what I wanted to highlight about that is it is either a very distinct central uplift or just a very defined area of high albedo. If a majority of the crater, especially the floor of the crater, is, say, an albedo of 5, this center, and gosh, only a tenth of the diameter of Pythagoras is an albedo of 2, maybe 3, but it is very bright and it stands out. And then between that crater and the actual, what is the horizon from here, there seems to be another crater right on the horizon, and right on the edge of that is another patch of that albedo. It seems to be between the two craters. It's hard to tell from this grazing angle, but there is another spot just further north beyond Pythagoras. Between the two, I can draw a picture of this one and show you where that very high albedo, again another 2 albedo surrounded by 5 and most of the area bounding it.
Integrity science, thanks for that. We agree with the Pythagoras assessment. And as a follow-up to your previous report, the SIR had questions about topography comparisons between the North Pole and the South Pole of the Moon, if you're willing to provide words on that.
Topography comparisons, absolutely. And if you have any idea what... if you draw a line between Pythagoras and the western edge of the outer defined ring of Orientale, it intersects a beautiful textbook crater on the south. I would love to know the name of that. The topography differences, now the South Pole has a little bit of a benefit that it has more of the terminator, and I can see a little more shadowing there, but there's a nice crater right at the South Pole, so that's the main thing defining the topography there. Seems to be quite a bit of elevation change. I can see some very jagged shadows, a 90-degree just to the west of that crater at the South Pole. I can see a very distinct change in the shadow directions, indicating, I don't know, a very high wall or a very deep canyon just to the west of that. And in the north, it seems to be that from sort of the edge of the mare that's dark, which is maybe 1 Pythagoras diameter south, if you draw a ring about that, maybe the top 7 degrees of the moon, and just draw a ring around that, the near side is an albedo of 5 and looks quite smooth from here. And then along the same edge of the mare, the edge of the mare that kind of Grimaldi's just outside of, Glushko is just outside of, Carroll Crater is just outside of, and you start to see the stark differences between the darker 7/8 and the 5s and 6s, the 4s and 5s. If you follow that line up to the north, that line is also where the change in topography happens at the North Pole. The line defining the light and dark on the edge of the mare that you can see from Earth. Draw that line, roughly the midpoint of all that, straight to the North Pole. And on the side facing the Earth, you see smoother topography and dotted by Pythagoras and its next-door neighbor crater. And then on the far side, you see a lot more cratering and a lot more topography. And again, the far side has the benefit of a little terminator there, but I am seeing a variation in the topography. It seems to be more jagged and a more challenging place to find a place to land and to even traverse in the south. All around the South Pole. And at the North Pole, it seems to be, it would be more challenging to to translate on the far side of the North Pole compared to the near side of the North Pole around Pythagoras.
Copy all, Victor. You really help paint a contextual picture of what you're looking at. We really appreciate the way that you're guiding us into the areas you're seeing by drawing comparisons between recognizable features. Thanks for that.
And Kelsey, another little science sit rep moment, something I just heard from the window team is the more I look at the moon, the browner and browner it looks. I thought that was an interesting observation. The two observers have been on timeline, no hardware issues. They did start to talk a little bit about another feature that you'll hear more about on the recordings that they call the handprint. That was at the end of their Glushko and before they moved into their current target. They thought that was worth chatting a little bit more about. And they're preparing to switch after this.
Houston copies and concurs.
Hey, Houston and science, integrity, another just observation from the human. My eyes have shifted a little bit since I've been up here. I've been wearing my reading glasses to look at the PCD. Well, this is a very taxing event on the eyes, looking out the window and seeing the very bright moon, then coming back inside to the dark cabin and trying to work cameras and microphones and logistics and lunch and those kinds of things, and then looking at the PCD, which is dimly lit. It's just been an exercise. It is a difficult thing to manage it. I'm up and down on the glasses and then having to wait as my eyes adjust when I come back in. As soon as I look back into the cabin from looking out the window, I can feel my eyes adjusting, and I just have to work through it as they adjust.
Appreciate that report, Victor, and know that we are prepared to read you up targets from the ground if that would give you the ability to keep your eyes focused on the moon and not having to swap between that and the PCD. Just let us know.
Yeah, we appreciate that, science, and we will also do that for the window teams, and we'll back each other up that way as well. But we appreciate that. We may take you up on that. Thanks.
Continued detailed descriptions from the Artemis II crew aboard Orion. Again, this is a test flight, the first time we've flown humans aboard this spacecraft. So every detail, even that it's difficult to look outside the window and then back at the PCD, that portable computing device, every single detail is appreciated as we prepare for future missions. Glover also mentioned that he is now wearing his glasses now that he's in space and that his eyes have shifted a bit. This is something that happens when our astronauts go to space. There is a fluid shift from the lower half of your body up into your head, and that can cause changes in your eyes. It's something that we have seen over time for some crew members, especially now that we have been living and working on the International Space Station for over 25 years. Again, it's clear that these Artemis II astronauts have undergone extensive lunar science training, including classroom instruction, fieldwork, and high-fidelity simulations. Training expeditions even took place in analog environments like the Icelandic highlands and the Kemasassen impact crater in Labrador, where crews practiced identifying and describing geologic features under varying conditions. Additionally, here at Johnson Space Center, Orion mock-ups were used to rehearse crew choreography, including three-dimensional space management with an inflatable moon globe to simulate the flyby. And while on Earth, the crew also used that small lunar passport that I mentioned with descriptions, photos, and prompts to help them study the features we hope they'll see. Now, this is a view from their lunar targeting package at this time, helping them determine what they're seeing on the moon, as well as on the left, keep up with what their next target will be. As you can see, we have got a long list and an exciting day ahead of us. It's now been 4 days, 20 hours, and 53 minutes since Orion launched atop the Space Launch System rocket from Kennedy Space Center in Florida with our 4 crew members aboard. NASA astronauts Reid Wiseman, Victor Glover, and Christina Cook, and Canadian Space Agency astronaut Jeremy Hansen. The Artemis II crew passed a major milestone today when they passed the Apollo 13 distance record at 12:57 p.m. Central, 1:57 p.m. Eastern. That Apollo 13 distance record was 248,655 statute miles from Earth.
And Houston, another observation, whole moon. When you look at the moon, something I've never seen in photographs before but is very apparent, all the really bright new craters. Some of them are super tiny. Most of them are pretty small. There's a couple that really stand out, obviously. And what it really looks like is like a lampshade with tiny pinprick holes and the light shining through. They are so bright compared to the rest of the moon.
We copy, Christina. Thank you. Looks like you guys might be doing it, but remind you to swap positions at the window and take your SD cards with you. We're loving everything that you're calling down, so keep it up.
Again, Orion previously surpassed that the Apollo 13 greatest distance from Earth by humans. That was 248,655 statute miles from Earth, and Orion now 250,294 miles away from our home planet. The spacecraft is 9,033 miles away from the moon and growing ever closer. At its closest approach, it'll be about 4,070 miles away, and we will make sure we confirm what that distance ends up being. This is an approximation and an estimate ahead of that moment. We're anticipating them to make that closest approach at 6:02 p.m. Central, 7:02 Eastern, when they are in a loss of signal, transiting behind the moon. They will be the first humans in over 50 years to fly behind the moon and lose contact with Earth. We will regain that contact about 40 minutes later as they reconnect to the Deep Space Network, emerging from behind the moon, and we will look forward to seeing an Earthrise. Again, the crew is currently in their position swap portion on their timeline. This allows crew members the opportunity and the experience of all roles necessary during today's flyby. Right now, those 2 crew members at the window have swap positions. Again, the crew at the windows swapping positions. Right now, that crew is Commander Reid Wiseman and Mission Specialist Jeremy Hansen, while Victor Glover and Christina Cook serve as their support flyby crew members. That's why you are hearing Victor and Christina during those science situation reports. Those voices will change in about 30 minutes when they take a turn taking photos and making annotations while at the window.
Houston, Integrity. I wanted to provide an observation or a little bit of descriptive nature on something that we saw on the first day we had good moon views. This was when we saw more of the near side, and the ground helped me out with identifying Mare Imbrium. Mare Imbrium, when you have the western limb also in view, looks completely different than the normal view we have of the near side. It is the most striking feature of the western limb view that we had, and the mountain chains that form its eastern side are very prominent, but they actually stand out more than I'm used to seeing even on the western side, and the whole thing just feels like a big bump. It actually looks like a large healing wound with a high albedo forming the mountain chain around the impact basin. And I just don't think I had enough chance to describe how striking it was on that western limb view as we were coming in a couple days ago.
Christina, science, absolutely love that, especially since that's a feature that all of us here on Earth can observe from home. So I'm sure tonight everyone's going to be going out and looking for evidence of that beautiful topography you just said. Thanks for those words.
The view on your screen coming from Orion, a camera mounted on the spacecraft's solar array wing. Toward the right of your screen, the near side is the hemisphere we see from Earth. That is identifiable by those dark splotches, which are ancient lava flows.
Science integrity. A question and a comment. Question is it possible that we're seeing a Schrödinger basin from this vantage point in the Terminator at the South Pole? And the comment is the rays coming out of are less distinct. We are not seeing the bright rays coming out of it, but the sort of 9 o'clock wedge that is formed by the change in albedo from the interior portion that is to the northeast to the surrounding lighter mare that's 270 degrees to the west. That 90 is very distinct and interior. You got some great descriptions from the two at the window about the colors in there, but in that darker part, in that wedge, you've got some really interesting color, even though the rays, the distinct difference in the albedo almost look like rays, but it's not the rays coming out. It's the just change in that albedo.
Integrity science, that is very intriguing, those color rays coming out of rather than sort of albedo. And as answer to your question, we do not think you can see Schrödinger. It's in darkness as of now. But thanks for that description, and it sounds like the pair at the window's got great descriptions that we're definitely going to dive into tonight.
Okay. If you could help me, I would still love to know what it is. There's a very nice crater. You're going to likely have a lot of pictures of it. What would be right in the terminator at the South Pole or close to the South Pole, where it's intersecting the terminator right now?
Yeah, Victor, we're assuming you're talking about, kind of if you're looking at the terminator, it's basically like 70% down from the North Pole. Is that where you're looking?
Contact, yes, that is where I'm looking.
Integrity Houston, that is an enabled caution for wastewater dump required. We have hit our limit. As expected, no crew action.
Copy, no crew action.
You are.
And Integrity Science, we're trying to figure out what you're looking at there. Is it like right on the terminator, or is it in the eliminated portion next to the terminator?
While we wait for a response from the crew, the terminator is that difference between day and night, or brightness and darkness, that you see on the moon. We see this from the International Space Station as well, looking down at Earth.
And Science from Integrity, excuse my space orientation adaptation. If you draw a line between Glushko through the center of Orientale, and then another line from Glushko through the southern tangent of Orientale, that line would almost perfectly intersect tangentially the crater that I'm talking about, and it is on the terminator. So yeah, I think I'm not looking at the South Pole. I was a little twisted.
That line description was really helpful. I have eyes on the SIR right now, and they are actively discussing lunar geography. We will be back with you shortly.
You're hearing a couple of voices today in Mission Control Houston. One of those is Dr. Kelsey Young.
Integrity Science, we believe that's Zeeman Crater.
Oh, I floated away from the speaker. Say it again, please.
We believe that that is Zeeman Crater.
Zeeman. Okay, and can you say the first letter? I may be pronouncing that wrong. What's the first letter of that word?
Zulu. It's Z-E-E-M-A-N.
Copy. Thank you for that. Yes, we've got a great view of that. And when I went back to the window just now, the view has completely changed. Our trajectory is taking us to a new view, and I'm looking more into Babalov. I've got a nice, great view into Babalov. I'm actually away from the window right now, so I'm going to go try to give you some bounding words on the view that we're seeing, but I've got to get back to a window in a minute.
Understood, Victor. You're defining new views of the moon in more ways than one.
Again, when you hear calls down to science or from science, that's Dr. Kelsey Young, the Artemis Science Flight Operations Lead here at a console in Mission Control. You also hear communications with the crew from Canadian Space Agency astronaut Jenny Gibbons. She is the Capcom for today. She is a backup Artemis II crew member. those calls from pilot Victor Glover asking about a feature he was seeing, specifically a crater on the moon. Meanwhile, the team here in the science evaluation room was actively working together to determine which feature he was describing. The teams at the window have continued to move through their targets, including Aristarchus Plateau, Reiner Gamma, and we are preparing for the cabin and window teams to swap. That's when we'll hear more from Reed Wiseman and Jeremy Hansen when they take on these support roles, while Christina Cook and Victor Glover are at the windows photographing and annotating. As we briefly mentioned, if you look towards the right side of the moon, essentially, this live view coming from a camera outside the Orion spacecraft, and if you look on the right side of the moon where you see those dark patches.
Wow, yeah, I wish I had some more time to just sit here and describe what I'm seeing, but the Terminator right now is just fantastic. It is the most rugged that I've seen it. From a lighting perspective, there are little islands. There are islands of terrain out there that are completely surrounded by darkness, which indicates some real variation in terrain. Up to the north, there is a very nice double crater. It looks like a snowman sitting there, in the 5-10 degrees below the pole in the Terminator. And then on the southern edge, there's almost like a hole. Looks like a hole, and it's the diameter of Vavilov size, just blackness, and then a wall of bright, and then it goes back to the black beyond the Terminator. So there's it looks like there's just a gigantic hole right there. 1 Vavilov diameter east of the Terminator. And as you go south, the Terminator is not a nice smooth arc. It's just jagged. There's almost a 110-degree turn in the shadow as opposed to the nice smooth arc, again indicating some really interesting variations. And I'm sure we'll get some photos of that. And then one of the craters further to the south of Vavilov, maybe halfway down to the South Pole, is not only looks like just a deep hole, and then there's like 2 island rays pointing off to the west and north that indicate very high ridges and very deep canyons coming up out of that crater. So again, just some really interesting visual illusions going on with the shadows there. Like I said, there look to be islands out beyond the Terminator, because some of the things, maybe even a Vavilov diameter into the Terminator are catching sunlight on the peaks up to the north and to the south. It's very, very interesting to see.
Integrity science, oh my gosh, that was an amazing picture you just painted. I glanced over at the SIR video and I literally saw fist pumps in the air. Those types of observations are things that humans are uniquely able to contribute, and you just really brought us along with you, so thanks for that.
That's awesome, Kelsey. Did you get a sit rep updating you on a slight change in logistics for PCD use?
Christina, this is Houston. We did not, but we will take it now.
We slightly changed the PCD plan for the window observers. The 2 window observers kept their PCD. So in other words, the one that window 2 went to window 3 and the one at window 3 went to window 2 when they swapped rather than staying at the window. We'll plan on all observers keeping the same PCD for all observations.
Copy, Christina. That makes sense to us, and good plan. We are coming up here on a cabin and window team swap. Let me know when you're ready for a quick vehicle status.
As you heard, science.
Houston, go for the vehicle system update.
Howdy, Reed. We don't have much for you. We just wanted to let you know that toilet right now is no-go for use as we stick with the predetermined limit for now. All crew members, please use CCUs. Otherwise, Orion is looking very good. And you have 15 minutes in this handover time where we expect Victor and Christina to switch to the windows and you and Jeremy to be in the cabin assisting. Let us know if you have any questions.
No questions at all, and they're in the swap right now. The first thing I'll tell you, I floated up to the docking hatch window and just what I'm going to call the Mari around Orientale just looks so different out the docking hatch right now. It's quite a bit darker. It's the same darkness, if not a little darker than Grimaldi, but it's cool after just being in the 400 mil for the last half hour. Looking up close, I got pictures of everything Ike was just describing on the Terminator. It really is a fascinating Terminator. And then Orientale just looks so dynamic right now. It's very three-dimensional out the docking hatch compared to what I was just looking at through the 400 mil.
We love it. We are getting a sneak preview from one of our SAW cameras at what you're looking at, and we see some of what you're describing. We cannot wait to see your photos. Thanks.
Yeah, Jenny, I wish you had some longer lenses on the solar array so you could see the whole moon, but man, it is, or the up-close moon, not the whole moon, but it is just fascinating here. It's so cool.
All right, MPO and INCO, take notes. We want a zoom lens on those saws next time. Thanks, Reed.
Affirmative.
As the crew gets ready to switch positions from the window crew going back to the support crew and the support crew flying up to the windows. This view inside the room, Capcom Jenny Gibbons speaking with the crew, Canadian Space Agency astronaut. The crew has continued to provide excellent descriptions of what they are seeing on the lunar surface. In this picture, or in this live view actually, from Orion and a camera mounted on its solar array wing, if you look at the dark portion on the right side of the screen, those are visible from Earth. That's considered the near side. Those are ancient lava flows from a time early in the moon's history when it was volcanically active. And if you look towards the left, there's that dark, large crater that appears to the left of those lava flows. That's Orientale Basin. It's about 600 miles wide, and it straddles the moon's near and far side. And this mission is the first time that humans have ever been able to see this with their eyes in the daylight. Again, you hear conversation about that Terminator. You have a great view of that as well. That's the difference between light and darkness on the moon. Victor Glover explaining that as a very jagged looking Terminator due to the peaks that they're seeing and the craters that they're seeing as they prepare to cross over the far side. You also heard Science Officer, the Dr. Kelsey Young, Artemis Science Flight Operations Lead, sharing with Victor Glover that his responses are truly something that only human eyes can discern or provide. So we've previously discussed how having humans observing the moon on this mission is being combined with lunar robotic data to help us maximize what we know about the moon. So part of that data comes from the Lunar Reconnaissance Orbiter, or LRO. This orbiter provides the robotic foundation that makes Artemis II lunar science possible. LRO has been orbiting the moon for 17 years, which makes it the longest operated lunar orbiter in history. And it's also the only American spacecraft dedicated specifically to lunar science and exploration. Artemis II lunar observations are designed to complement data like the detailed surface images from LRO. So while LRO provides those detailed high-resolution maps of the moon's surface, the Artemis II crew adds human observations that focus on regional context and relationships between features, giving scientists a larger geologic picture. Now, this combination of robotic and human observations strengthens lunar science. LRO delivers precise and repeatable measurements over long periods of time, while the Artemis II crew contributes real-time visual descriptions and context that robotic instruments alone cannot provide. The best description I've heard while preparing for this mission is to compare the difference in looking at the moon with your own eyes on Earth and trying to take a picture with a camera. The camera truly never does it justice, and it's much easier to describe and perceive what you're seeing with your own eyes than to take a photo. These Artemis II astronauts can rapidly scan wide areas and adjust their focus in real time, as well as describe relationships between features. The crew will also observe the same regions multiple times under changing lighting conditions during the flyby and provide perspectives that would take robotic missions years to accumulate. During the Artemis II mission, LRO is also attempting to observe some of the same lunar features that the astronauts are studying. Collecting this data simultaneously highlights how different instruments and human eyes provide complementary information about the moon. This LRO data plays a direct role in preparing for future Artemis missions. Its measurements of topography, surface temperature, composition, radiation, and lighting conditions are used to assess hazards, identify safe landing sites, and locate potential resources such as water ice near the lunar South Pole. This mission, Artemis II, represents the point where years of robotic preparation are paired with human exploration for the first time in the Artemis era. So together, LRO, the Lunar Reconnaissance Orbiter, and Artemis II are demonstrating how NASA moves from mapping the moon robotically to exploring it with humans. We are laying the groundwork for future Artemis missions and sustained lunar operations. A check-in with Orion. We are now 4 days, 21 hours, and 22 minutes into the flight of Artemis II, our crew aboard the Orion spacecraft. We are now 8,153 miles away from the moon, 250,742 miles away from Earth. The spacecraft is traveling at 1,030 miles per hour.
The professional science update giver is now in seat 2. That is where Victor is, and Christina is nestling into seat 1 with the long lens, and we're just getting ourselves oriented here. It's a cool view in the cabin. It's actually a cool view to be off the camera now and looking at my crewmates getting up to their observation posts and looking in
SBL read. We like it.
As we heard confirmation from NASA astronaut and commander of Artemis II, Reid Wiseman, they are now switching positions of the support teams and the observation teams. So initially, Reid Wiseman and Jeremy Hansen were at windows 2 and 3 in the Orion spacecraft, taking photos and making annotations in their PCDs, portable computing devices. They were also giving audible descriptions into their PCDs, wearing headsets with microphones and providing recordings that the science team will be able to listen to later. We were hearing from NASA astronauts Christina Cook and Victor Glover as they made observations as part of the support team. Now, as these teams are swapping, we anticipate hearing more from Reid and Jeremy as they'll be on the support team, while Victor and Christina will be at the windows taking photos and making annotations.
for the science team if they could mark this time. I just covered up window 4 to block out the ambient light from a very bright planet Earth. And it'll be interesting to see if in the data Victor and Christina see any differences from me and Jeremy with that window blocked. It's a lot darker in the cabin now.
Copy, Reed. We're taking note, and we'd be curious too.
We are live in the Artemis mission control room during the lunar flyby of the Artemis II crew, the first humans to fly by the moon in over 50 years. Orion launched 4 days, 21 hours, and 30 minutes ago atop the SLS rocket, Space Launch System rocket from Kennedy Space Center in Florida. Our 4 crew members inside the spacecraft are transitioning their positions. The cabin and window teams have swapped. Currently at the window, we have Victor Glover and Christina Cook, NASA astronauts, and serving as support, Reed Wiseman and Jeremy Hansen. For our crews at the window, they are using handheld Nikons with an 80 to 400 millimeter zoom lens. There are also GoPros on each of the solar arrays on Orion, and that's where this view is coming from right now. We have an interior camera of the crew as well, but they have dimmed the cabin lights. They've actually turned off the cabin lights to allow them to better see outside of the spacecraft. This also helps prevent any reflections from lights inside the spacecraft reflecting onto the windows while they are photographing the moon. We talked a little bit about the views and the cameras being used on the Orion spacecraft. And again, we do have GoPros on the tip of each solar array wing. Now, the bandwidth is a little bit limited because having a crew on board, we do have to downlink a lot more data. That includes their environmental control and life support system. We are not the only data, this view that you see, coming down from the spacecraft, and so we do rely on sharing some of that with the other flight controllers in mission control. This helps the team monitor all systems aboard the spacecraft and ensure the safety of our astronauts. We are standing by for a situation report from the crew aboard the spacecraft. They've been imaging the whole moon. There is now a new crew at the window. That would be Victor Glover and Christina Cook. And so being it's their first time since they have moved up to the window positions, they have a chance to orient themselves and describe and take pictures of any color or albedo variations across the surface. Reminder, albedo is the brightness or reflectiveness.
Integrity science for a science sit rep when you're ready.
Houston Integrity, we have no external view of the moon right now for the floating crew members, so my only science sit rep is that we have Victor in window 3 doing observations and Christina in window 2 with the long lens.
Integrity, we copy. Are the shrouds still on windows 1 and 4? And if so, would you consider trying to get a view through one of those windows?
We cannot take the shroud off of 4 because the Earth is too bright and it's impacting Ike's peripheral vision. And then I can get a grazing glimpse out the docking hatch window. I can see Orientale south down to the South Pole. And the primary thing that I see from Orientale right now is just the long trenches that come out. And, you know, when you come out the north side of Orientale, the ejecta kind of boulders across the northern half of the far side. But coming out the southern half of Orientale, I just see those large, here they look like gorges. They're almost like rain when it comes down the Grand Canyon and fingers off into the desert, kind of what it looks like. Also, Burgess Alpha is extremely bright. It's the brightest thing that I can see. Even brighter now than Aristarchus, which is heading off to the Terminator. It's almost impossible now to see Aristarchus, the thing that Jeremy and I looked so much at. I can just barely see the crater rays from Ohm, and I would say for albedo right now, I would go back to Grimaldi is still extremely dark, especially in that southwest corner, and there are parts of Orientale and the outer ring of Orientale that reach that same level of darkness, especially the rings of Orientale reach the same level of darkness as Grimaldi. And then south of Grimaldi, Jeremy and I were noting a few other just really dark areas of cratering, mare there, and those have that same darker albedo. But Burgesshoff is the brightest, and Grimaldi is the darkest.
Integrity Science, that was a great description. Thank you, and thanks for the docking window geometry to give us that description. Any comments before you go on the annular ring in Orientale?
The annular ring, which I think everybody kind of describes as like a pair of lips or a kiss on the far side of the moon from here, is very circular in nature. The northern part of it is wider, darker. The southern part is much lighter. It is very neat looking, and but it is far more circular than I remember it looking in our training. The darkness of the northern side of the annular ring is the same darkness from here out this docking hatch window as the center mare in Orientale. Not quite as dark as Grimaldi, but it is probably only because dust and lunar regolith has kind of impacted over time.
Reed, that's exactly what we were looking for. Thanks so much. You have heart hands coming out of the SIR.
Say that again, Kelsey.
Just saying that the SIR was really excited about that. That annular ring was something we were really eager to hear about, so thanks.
Yep, you bet. And now Victor and Christina are moving on to Orientale. I got them situated over there a little bit late.
That was NASA astronaut Reed Wiseman, now providing a science sit rep as he is away from the windows most of the time. He is working as the support person along with Jeremy Hansen in the spacecraft, as Victor Glover and Christina Cook are now at windows 2 and 3, able to photograph the moon. Christina and Victor are also providing recorded information to their portable computing devices, that's their PCDs, and the science team will have access to that at a later time. They will then review it and compile all of this data to help further our understanding of the moon. One of the items you heard mentioned was Orientale Basin. This has been a very exciting opportunity for the crew. They have all been very excited about seeing Orientale, as well as the science team has been looking forward to it. It is known as the Grand Canyon of the Moon, as we discussed earlier. From the pictures, the science team is hoping that the crew will take centered images of the entire basin and surrounding craters in a single frame, but also use those 80 to 400 millimeter zoom lenses to create a mosaic entire basin. With their unaided eyes, the science team is hoping the crew will describe southern dark annular ring, which you heard Reed just describing, as well as any color, albedo, texture, or topography across the mare patches and ring mountains. The science team reports that the observations will be used to study the geologic evolution of the youngest lunar basin and to inform formation hypotheses for the annular ring. And again, another fun fact about Orientale is the diameter is the same distance between Johnson Space Center, where we are today, and Kennedy Space Center, where the crew launched on April 1st. This live view from the Orion spacecraft on the Artemis II mission, now 7,373 miles away from the moon, 251,130 miles from Earth. Again, the Artemis II crew passed the Apollo 13 record of the humans farthest from the Earth today at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance set by Apollo 13 was 248,655 statute miles. We have clearly passed that, and we expect to pass that by about 4,105 miles. That will be when the spacecraft reaches its farthest distance from the Earth. It could be around 252,760 miles, but again, these are approximations and our targets, and we will make sure to report back the final numbers once we have them. We have some refined times of when we expect to have Earth set of Earth behind the moon while Orion flies behind the moon. That would be about 5:41 p.m. Central, 6:41 Eastern. The spacecraft would make its closest approach to the moon at 6 o'clock Central, 7 Eastern, and that would be about 4,066 miles. And then at 6:02 p.m. Central, and the spacecraft will reach its farthest distance from the Earth. We anticipate that'll be about 252,755 miles, which would be 4,111 miles farther than Apollo 13. We would see Earthrise again at 6:21 p.m. Central Time, and a few minutes later, regain communications with the crew. Currently aboard Orion, Victor Glover and Christina Cook are the two team members conducting lunar flyby observations, meaning they are using the Nikon cameras to photograph the moon, and their PCD, or the portable computing device, to conduct annotations. They are both recording information that will be downlinked to the science crew, and tomorrow morning the science team will have a conference with the team while the information is so fresh. They'll be speaking with the crew about their observations and their data collection. Otherwise, most of tomorrow, flight day 7, is considered an off day. We are on flight day 6 of the Artemis II mission, the first time in more than 50 years that humans will observe the moon directly, providing a critical opportunity to practice how lunar science will be conducted during future Artemis missions. If you're just joining us, the crew is well into their lunar flyby observations, and we anticipate that we will hear from them soon. A few times every hour, they are slated to call down with science sit reps or situation reports. We most recently had one from Commander Reed Wiseman. He and Jeremy Hansen, mission specialist, were first at the windows today to photograph and make annotations of what they were seeing. Therefore, we heard more from Victor Glover and Christina Cook earlier in the day during those first blocks. But now that Reed Wiseman and Jeremy Hansen are on the support side, they are the ones calling down what they are seeing from windows 1 and 4. Earlier, we heard that the Earth is so bright in window 4, they have had to temporarily cover it with a t-shirt. The moon preserves a near-continuous record of solar system history that has been erased on Earth because the moon doesn't have an atmosphere. So things that we experience on Earth, like weather or plate tectonics, don't really apply. So the lunar surface retains evidence of ancient impacts, volcanism, and solar activity that scientists can study today. And studying the moon helps scientists understand how planets formed and evolved, how the moon influenced our own planet Earth's history, and how the sun shaped conditions across the inner solar system. The moon also serves as a unique platform for studying the broader universe. Artemis science is designed around questions best answered by humans, working alongside robotic systems, combining decades of robotic lunar data with real-time judgment, context, and adaptability that only humans can provide. This mission, Artemis II, is serving as a proving ground for lunar science operations, which allows NASA to test how science is planned, executed, and supported during a crewed deep space mission ahead of our future Artemis flights.
Integrity, time for a window team position swap. So Victor and Christina, please switch places if you've not done so already, and remember your SD card for the camera.
We're in the swap right now. They're wrapping up their last comments, and they'll switch over and change cards from the long lens.
Copy.
As you heard in that call, it is now time for the team members at the window to swap positions. That means Victor Glover and Christina Cook will be switching roles. One of them has been photographing the moon with a Nikon with an 80 to 400 millimeter zoom lens, while the other was making annotations on their portable computing device. And both are recording audio that the science team will be able to listen to. We are now 2 hours and 10 minutes until we expect to lose signal with the spacecraft as they fly behind the moon. And the next target for the crew is considered a crew choice event. They have the option to focus on any regions or patterns or features that interest them. The science team has asked the crew to capture pictures that illustrate their choice, as well as at different zoom levels, and to describe why those certain features or regions caught their eye. Those recordings are part of what are being saved on their PCDs, portable computing device, that will be sent to the science team for analysis. The crew has been allotted 8 minutes for this crew choice event, and it's also a time for a scheduled sit rep or situation report. So we expect to hear them calling down what they are seeing soon. Something that the crew or that the science team has used to help prepare the crew is a cue card. These ask for a feature ID if they happen to know the type or name, and if it is a target. Of course, in this situation, when they have a crew choice, they do not need to, it may or may not be a target. They want to know the location and the observation style. They've also asked for the geometry of what's being captured, the size, shape, boundary, and preservation, as well as the color and shadow, so the color tone, the albedo, that reflection or brightness, and any shadows or illumination. Next, they're interested in structure and texture. That includes slopes, structures, and textures, of course, and geologic relations, like association to other features, any contact to those features, and of course, their thoughts, impressions, or interpretations. They are interested even in emotions and excitement that the crew may be having. This flyby day has been practiced in many ways, even in sims here in Mission Control Houston. The team also conducted some field work, learning how to look for specific geologic features. They also photographed a large globe, and the science team helped them determine which features they would be targeting and how to look at those. We have a few more minutes that the crew would be photographing their crew choice. Again, this is NASA astronauts Victor Glover and Christina Cook at the windows. They will then move on to another discussion portion. This is for the far side albedo, that reflectiveness, and color that they are seeing. We heard earlier about some browns seen on the moon, which is very interesting, especially here from Earth, where we are just seeing whites, grays, and maybe even black at some points. When they get into that discussion for far side albedo in a few minutes, the theme is looking to know how that color and albedo is, what those variations look like across the far side. On the right side of your screen, the Science Evaluation Room, or SIR, where team members are looking real time at what the crew is seeing. And even earlier, we're...
Houston Integrity, you ready for science zero?
We'll take it.
Okay, the crew has swapped positions. They're in their crew choice. element. I've been listening to both of them for a little bit, and they're really enjoying. They both decided to pick the Terminator, and they're spending a lot of time looking at the Terminator, just talking about the resolution that they can see, the depth of the craters, and the various interesting and unique excavations that they can see. So Victor is on the long lens, and Christina is just looking out the window, and I'm sneaking a peek in T-shirt window. It looks like, I don't have the best angle here, but it looks like Aristarchus is on the limb of the moon now. It's amazing how quickly it changes as we speed around the far side of the moon, stuff that's leaving our field of view, and now we have a lot of the dark side of the moon that, you know, it's missing for us right now, but it would be in view if it was lit at all.
Jeremy, Science, thanks for that sit rep. Do have a question. A few times we've heard you and the other crew describe change during the course of your flyby. Would be interested in future descriptions of more verbosity about how it's changing. Thanks for the great sit rep.
Yeah, Kelsey, sounds good. We are definitely keeping an eye on that. My eyes have just not readjusted. The moon is so bright when you come back to the window. I was just in the interior of the cabin. I've come back to T-shirt window, and it's just overwhelming brightness, and my viewing angle is a bit challenging, so I won't be able to give you great observations from this window. But I will talk about something that I was talking a lot about in my recordings earlier, which was we've been talking about some shades, and so we have obviously the dark and the light gray, and then we've talked about naming some colors, a brownish hue and a greenish hue. And I'll tell you, like right now, Aristarchus, the plateau is hard for me to see from this window, but that had greenish hues to me and was very unique. I didn't see anything like that anywhere else on this side of the moon. And then I see a lot of these, what I would call brownish hue areas. There's a number of them. And they, for example, in the northwest corner of the highlands, to me it looks like the brownish hue is caused by ray or ejected material landing on the highlands, and then we obviously see the ray areas as a lighter albedo, but in between the rays where the deposit would be thinnest, that is what it looks like is causing the brown to me. So I saw that in the northwest side of Aristarchus, or sorry, that dark area of the highlands, northwest side of the highlands. I saw it in the highlands to the east of Glushko, and then I see those same brownish hues west of Orientale, and I drew a contact there on OneNote, but that's a huge region, kind of like a piece of pie with the point of the pie pointing at Orientale and then going up towards the northern side of Hertzsprung. And that is an area that just looks like that brownish albedo.
That was fantastic, Jeremy. We had heard rumors of the green and brown hues, and so you really read my mind on asking about those. Understand they likely didn't have any contact with each other the way that you described them, but please correct me if I misunderstood that. And then last thing, I'll make the same offer we made to Victor earlier. If it would be helpful for us to verbalize any targets so you can stay at the windows and keep your eyes adjusted to the moon, please let us know.
If you got something you want us to look at, Kelsey, you can send it on up.
Definitely not looking to interrupt your flow, Reed and Jeremy, only offering assistance if you guys want to keep your eyes off of the PCDs.
Oh, I see what you're saying, okay. Not really science related, and we definitely learned this in Apollo, but the thing that is just most fascinating, I think, to me and Victor right now is even as rugged as the far side looks, when you look at Orientale and Home, it's rugged. But man, when you look at the Terminator, it is just like impossibly rugged, and it reminds you that the whole far side is that way, and just the Terminator is really bringing out the shadows and the hills and the valleys, and it is just, it's unbelievable. It's like no surface of the Terminator is not marked by meteor impact, and it's just, it is very impressive to look at that, and you realize that that is true across the whole far side. You just can't see it due to sun illumination right now.
Reed, Houston copies, and we were commenting on the same thing. Even from our view, the Terminator looks absolutely alien because there's just so much texture in there that we're just not used to seeing. So thanks for sharing that with us.
There's also, I don't know the name of it, coming out the south-southwest of Orientale, right on the southern Terminator, is just a massive crater. I don't know the name of it. Maybe you can look on the solar array wing video and tell me it's right. It's the southernmost crater you see on the Terminator right now.
We're looking for you. We're loving that picture. Thanks for showing us. And Reed, as an answer to your last question, we believe that that is Chebyshev crater. And the sir agrees with that.
Okay, that picture I was just showing you is an 8X iPhone out the docking hatch for the high grazing angle. It's just amazing.
We love it. Thank you.
This is Artemis Mission Control in Houston, Texas. Mission elapsed time, 4 days, 22 hours, 12 minutes into the flight of Orion. This is Lunar Flyby Day for the crew aboard the spacecraft. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are now the farthest people to have ever traveled from Earth. This a live view from inside the spacecraft. They have turned off the lights so they're able to see outside and photograph the moon better with no reflections from inside. And for a very brief moment there.
Integrity Science, thanks for those iPhone views. It's helpful to see what you're seeing.
We very briefly saw NASA astronaut Reed Wiseman showing a picture he took on his phone of the moon. We do expect to get all of the photos that the crew is taking today, and we cannot wait to share some of those with you. But pretty cool in the meantime, just to see one quick shot from what the crew is seeing. And this view from outside the spacecraft on Orion's solar array wing. Orion is now 6,643 miles away from the moon and continuing to grow closer. Again, their closest approach will be about 4,066 miles. The best comparison is if you held a basketball at arm's length. That's about what it would look like to the Artemis II crew at their closest approach. This view showing at the very top, a camera coming from Orion, continuing their flyby of the moon. We have 3 more flyby observation blocks after the completion of this one. Down on the bottom left of your screen, that's the SIR, the Science Evaluation Room, where team members are continuing to work through all of the targets that the crew is photographing today, and they've helped identify some of the craters and some of the other items that the crew has seen on the moon's surface. Down on the right is Artemis Mission Control here in Houston. Those 2 rooms down at the bottom are just down the hall from each other. And we are just a few minutes away from the next cabin and window team swap. That means Victor and Christina, who have been at the windows, will fly to the cabin, the background essentially, and be their support crew for Reed and Jeremy. Reed and Jeremy will move back up to the windows. The crew is continuing their discussion portion of the flyby in the lunar targeting package, where it says far side albedo/color. They are looking. The science team is looking to get a good understanding of what the crew can see on the far side at this point, and its brightness as well as any colors. We did hear earlier Canadian Space Agency astronaut Jeremy Hansen reporting that they could even see browns and even greens on the moon. I'm really looking forward to seeing those photos. And in just a couple of minutes, the teams will swap from the cabin to the window. Another rundown of just how this flyby is choreographed inside the spacecraft today. So these activities have been timelined, and there are these 5 blocks of time during which the crew is going to be observing the moon from Orion's windows. Now we are just coming up on the end of the second block, and we'll start the third soon. So at any time during those blocks, 2 members are at the windows working in a pair. One is taking photos from window 2 and has a blue shroud over the window to help prevent any reflections from inside the spacecraft. They are also using an 80 to 400 millimeter zoom lens. And the other astronaut on the window team will be in window 3 using their portable computing device to make annotations. Now, again, both of those crew members are making audio recordings of what they are seeing, and we are not hearing that right now. Those are going to be downlinked later to the science team, who will evaluate them and use that data to inform our understanding of the moon. Those 2 crew members at the windows swap roles.
Integrity Houston, it is time for another swap between the cabin and the window teams. So we have 15 minutes of handover time, and then we will expect Jeremy and Reed at the windows and Christina and Victor at the cabin. I have no new vehicle updates for you, but I do have a photo location for some photos on Ike's PCD, and I want to let you know that Jeremy's family have arrived in the viewing gallery.
Okay, Jenny, we copied most of that. The only thing we're missing is what you meant about the photo location on Victor's PCD. And hello to my family. I think that must be Catherine and Devin that are there. And I'm glad they made it into the viewing room. And we copy, it's time for crew swap. The A team's coming out of the windows and the B team's going in.
Okay, copy. All I meant to pass for Victor's PCD is that there are some late load photos that were requested that are now in his favorite photos folder. And you're exactly right. We have Catherine and Devin here. They give you a big wave, and they're super excited and happy to see part of what you're seeing.
Okay, copy, Jenny. We're not sure what we're looking for in the PCD, but we're going to poke around, and we may be calling you back about that one.
All right, that's no problem, and it's unrelated to flyby.
This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. And as you just heard, Capcom, or Capsule Communicator Jenny Gibbons, Canadian Space Agency astronaut and Artemis II crew backup, relaying to the teams in Orion that it is time for a swap from the cabin to the window teams. We're now at the tail end of the second lunar flyby observation block. Again, we have 5 of these today. Most recently, Victor Glover and Christina Cook were at the windows photographing and making annotations, while Reed Wiseman and Jeremy Hansen were in the cabin providing support, whether that is SD card help, but also science sit reps, calling down any situation reports for what they are seeing on the moon or anything about the vehicle status. With that call to make a swap, Reed and Jeremy will be back at the windows, making observations for what they see at the moon and taking photos. Again, you're watching live coverage of NASA's Artemis II.
But something that's really awesome up here is we now have the moon and the Earth in window 3 simultaneously, and the moon is a gibbous, and the Earth is a crescent. And I'm guessing in about 45 minutes we'll have 2 identical crescents as we change our position in the universe.
That is pretty darn cool. Thank you.
That's the Artemis II crew, the first astronauts to fly by the moon in more than 50 years, reporting that when they look out of window 3, one window, they're able to see both the Earth and the moon at the same time now. Now, obviously, our view is from a camera on the solar array wing pointed at the moon, and we hope to see that view of both the Earth and the moon soon. Some upcoming times for what you can expect. In about an hour and 40 minutes, we will have Earth set. And during that time, we will have a view of Earth going behind the moon. Shortly after, just a few minutes later, we will lose signal with the Orion spacecraft. This is tracked as it is going behind the moon and out of reach of the Deep Space Network. At 6 o'clock p.m., the spacecraft will make its closest approach to the moon at a distance of about 4,066 miles. At 6:02 Central, the spacecraft will reach its farthest distance from Earth at about 252,755 miles. Of course, these are approximate, and we will make sure to provide you with the final distances once those are confirmed. At 6:21 p.m., we will have Earthrise from the Orion spacecraft, but we will not have communications with the spacecraft until 6:25 p.m. Central, when we expect to acquire signal with them after they've emerged from behind the moon. Again, you're watching live coverage of NASA's lunar flyby for the Artemis II mission, first crew to fly beyond the moon in over 50 years. The astronauts inside the spacecraft are switching positions, 2 at the windows and 2 serving in support roles, before they start their third timelined flyby observation for today. We've heard great calls from the crew so far describing what they're seeing, all well trained by the science team here on the ground. Another major milestone for the crew today will be to experience a solar eclipse from their capsule. No one on Earth will experience this solar eclipse. To the astronauts, this will look a lot like a total solar eclipse on Earth, except the moon will be huge compared to the sun. Whereas if you're standing on Earth and looking at a solar eclipse, the moon and the sun appear to be about the same size in the sky. As the moon begins to cover and then uncover the sun, the astronauts will see a partial solar eclipse, so that's before and after totality, and during that time frame they will have to wear eclipse glasses so they can safely view this phase. They also intend to capture images of the sun's corona during the eclipse. This is a rare glimpse at the innermost corona that will only be captured by the astronauts' cameras. During the eclipse, we also look forward to the crew members describing what they will see, which includes unique light features like the shape and size of the corona and potentially even lunar dust. At the same time, Venus, Saturn, Mars, and Mercury will be near the sun, so they may be able to identify what part of the sky they're looking at. This can help train future Artemis astronauts on what part of the sky they're seeing, which is useful knowledge in challenging situations when they may need to rely on that information instead of instruments for navigation and orientation. That eclipse window will last about an hour, and it'll happen near the end of the day today, closer to 7:35 p.m. Central, 8:35 Eastern.
the press briefings and content that, we've been putting out, color and albedo were really exciting targets for us. We've heard several amazing color descriptions so far. Just to highlight maybe one of them, we heard about greenish and brownish hues near Aristarchus, which is actually a feature that we can see here from the near side. And those greenish hues could actually tell us something about the volcanic evolution of that area. So you can bet that the science team is going to be prioritizing downlinking those images and the crew audio that we didn't hear that went into those recordings to learn a little bit more.
Wow, that is fascinating. I was hearing those colors and very interested just from a personal standpoint, because looking at the moon from, 250,000 miles away, we don't see green or brown. So just hearing that, them being so close and getting to see that, fascinating, and I know very exciting for you. So what are you expecting to see in the upcoming portion of the flyby?
The upcoming portion is actually going to be really exciting. So right now, as we speak, while folks in the room are kind of taking their, their stretch breaks and everything, the crew are still hard at work. They still have targets to image and describe during this LOS. But when we come out, the first thing, of course, we're going to hear about is Earthrise. We're really looking forward to hearing about the crew's experience with something that we can connect with and that, Apollo 8 brought us such amazing images from. But then we start to get into describing the Terminator, as well as looking for things like lofted dust, which tell us about the modern lunar environment. Then the vehicle's going to orient away from the moon for an hour and then pivot back for the eclipse observations, which is a whole different set of science observations that we're really looking forward to.
It's kind of nice that the crew will get a little break in there, because they have been hitting it hard today with photos and videos and annotations. What are you hoping that the crew sees coming up? Is it that lunar dust?
Oh my goodness, that's a hard question to answer. I mean, we've already gotten such great descriptions. I mean, the Terminator seems to just be like one of their favorite things to look at and describe. So I feel like, that was something we were looking forward to. I feel like we've really gotten some great descriptions. So absolutely, I'm looking to the human moment of Earthrise. Lofted dust is an exciting one, and lofted dust will be a target for them in the right around the time of Earthrise, but again in the eclipse period. So I'm really looking forward to seeing. I mean, they've already highlighted just in the course of their flyby so far how the moon has changed, and this is going to be even more dramatic change to go from their end of this kind of lunar illuminated piece of the flyby into the eclipse time frame. And I can tell you they're going to be experiencing a very different moon during that time, and I can't wait to hear what their observations are.
Yeah, that's absolutely fascinating, and what an privilege that we get to do that on this mission, because that's not always the case. If we had launched on a different day other than April 1st or 2nd, we wouldn't have gotten to see that eclipse. Is that right?
That's correct. April 1st and 2nd. I will say, I was asked a lot in the weeks leading up to the launch, well, what's your favorite day? And my answer truly was, there is no bad day to launch to the moon. We were going to get great science out of it no matter what, but it's a really neat opportunity to, bring the sun into the picture, bring different planetary bodies into the picture while still literally keeping the moon in center stage.
Fascinating. So what differences are we looking for at each site? We're hearing a lot of different terms. We're looking at craters. We're looking at mare. What are the differences that you're hoping to see?
We do have, as you highlight, kind of different prompts for each target. That's what they're looking at in their lunar targeting plan, which I know you've been showing. And we have even different prompts for the person with the, the really long lens on the camera versus the people with the unaided eye. And you've heard the crew talk about, oh my goodness, when I go from one to the other, I can really detect different nuances. And that's something that we experienced in simulations, but hearing them actually, see it for real has been really gratifying. But we're looking for different things based on the target. Sometimes we're looking for color. Sometimes we're looking for texture. For the Terminator, we're looking at kind of what texture and morphologies pop out to you and what kind of diversity you see along the Terminator. You've heard, Victor especially make some comments about future impacts for exploration. So already I think that their descriptions in this first part of the flyby have told us something scientifically, but also about future surface missions.
Well, it was so interesting to hear Victor talking about he was imagining in his mind's eye being down on the surface and walking around. That was very cool to hear. And when we're thinking about targets, I know some of them are determined based on the launch day because that determines the lunar illumination. So the ones that we're looking at today, how and why were these selected?
Such a wonderful question. This really gets at at the heart of some of our really highest priority science questions. Illumination conditions is a big one, right? So, of course, we need the targets that we're interested on the lunar feature to be illuminated by the sun in order to view them. But the timing in which they see them during the flyby enables us to ask different questions. So you heard in the pre-flyby crew conference talking about, well, the same pair, Reed and Jeremy, will get to actually look at Glushko crater twice, and that looking at it from different illumination angles allows us to understand that feature better and connect color and albedo with topography and morphology. Then you have other craters where you want to look at it with the sun shining on it obliquely versus straight on, and that tells you something different about the scientific objective that drove the target being on the targeting plan in the first place.
We've talked a little bit with the viewers today about what the crew is able to capture in this short time frame of those craters in different lighting conditions. Could take years for something robotic to be able to do based on attitude maneuvers and where the sun is at. So can you just talk a little bit about the importance of having both the robotic operation and having the crew?
Absolutely. We definitely don't want to minimize the impact of orbiting spacecraft. Lunar Reconnaissance Orbiter is the one that's often referenced. Data from LRO and its payloads have really been instrumental in getting us, frankly, to this point for Artemis II and future missions. But the human experience, the crew observations that we've already been hearing about, it is such a perfect complement to the orbiting spacecraft data because they are able to have this unique perspective. They are far enough away where they can make these contextual observations. You've already heard it. How many times have we heard the crew and their science sit reps say, if I track this feature from all the way up here in the northern hemisphere down to the southern hemisphere, here are comparisons I can make. That right there is not something we had the ability to do with the Apollo missions, and it allows just literally in the blink of an eye to synthesize observations that it would take, a really significant effort to coordinate with different orbiting platforms, and they're making it like that.
Wow. It has been very, very exciting to hear all of their calls so far. And so I've heard they were able to capture every single target so far too. Is that correct?
I think that's correct. And I think it's important also to remember that, and I know the science team is anxiously awaiting this, we've been hearing from the crew members who are not at the forward windows, right? Those crew who are, really in the thick of the observations, they are recording minutes-long observations per target on their crew tablets. We will be getting those down starting here in a couple hours, and that's going to contain really meaty science information that we haven't heard live yet, and that's going to form the basis of my conversation with them tomorrow morning, where we're going to have a really deep dive into the science and absolutely nerd out about what they were able to do today. One of the most gratifying things for me today is hearing multiple crew members say, thank you for putting the discussion times in the targeting plan, because when we have had the ability to put multiple brains on a problem, we have elevated each other. And I'm looking forward to them, sleeping on it overnight and then us actually being able to really, truly have an elevated science discourse tomorrow.
Well, we're looking forward to it too, and I cannot wait to hear everything that you guys get to learn overnight from some of those audio recordings and just everything that they'll be able to share tomorrow. So, Kelsey, I know you are very busy. You've done a great job today, and thank you so much for joining us for this interview.
Thanks for having me. It's such an exciting day.
We are now expecting acquisition of signal in about 24 minutes. As a reminder, the Orion spacecraft has flown around the other side of the moon, where they are out of contact with our deep space network. And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds. And we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon. We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the of the moon, the Earth now out of sight. What they're in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis II. We're live in Mission Control Houston at NASA's Johnson Space Center, but there's a team over 750 miles away also monitoring today's operations. And of course, just like us, they are in LOS, or loss of signal, with the spacecraft. This is LUCA, the Lunar Utilization Control Area, and it's joined by LISA, the Lander Engineering Support Area, which are twin control rooms that will support missions and operations in lunar orbit or on the moon's surface in real time at NASA's Marshall Space Flight Center in Huntsville, Alabama. The LUCA and LISA are right next to each other and just a short walk away from the SLS Engineering Support Center, which is used during launch, and the POIC, where science on the International Space Station is monitored. LUCA primarily supports Artemis science operations, while LISA will provide engineering support for landing astronauts on the moon. During this mission, Artemis II, teams in the LUCA will use the facility to support first-of-its-kind science operations to better understand the deep space effects of microgravity and radiation on the crew's physiology, immune systems, and ability to complete various tasks. The data from these science operations will inform future crewed flights to the moon. For future crewed missions to the moon, members of the NASA Human Landing System Mission Insights Support Team, a group of engineers, safety leads, flight operations experts, and technical authorities, will work in the LISA. There, they will monitor lander systems in real time and be involved in key decision-making processes throughout the mission. Teams are using the LISA during Artemis II to observe mission operations and using the opportunity to inform and prepare for future crewed landings to the moon's surface. We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis II visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis II crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis II is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration. Artemis is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis II will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close, and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Orientale. Orientale is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Orientale has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission.
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby. The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the Deep Space Network. Right now, they are imaging or attempting to image lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.
I remember being a little kid lying in bed at night and just looking out at the moon in whatever phase it was in, and I was thinking, man, my friends that live like 20 miles away, they can probably look out and see that same exact moon. And then when I was in the Navy and I would look out at the moon and I'd be halfway around the planet, and I would think, man, my brother can see that moon where he is, and he's halfway around the planet from where I am. And it's a connection of life on Earth. We can all look up and see that moon.
It represents history. It is a witness plate. Everything that's ever happened to the moon is still written on the moon. There's no processes of wind or change in the Earth, geologic processes like we have here that change it. And something that's been telling and can read out the story of its own evolution, there's something beautiful about that.
I've also learned from my indigenous mentors that they refer to the moon as grandmother moon. So you've probably heard of Mother Earth. They use grandmother moon because grandmother moon is responsible for the water in their community. The grandmothers, sort of protect the water source, just like the moon moves the water around the planet, affects the tides. It's something that represents something different for each individual culture around the planet. And that's really neat because we all share that same moon in the night sky.
We all have seen the same side of the moon in different lighting conditions our whole lives. And so it seems very familiar to us, but it's also kind of unknown. When we get up close, some of the imagery that we'll get to describe and to share with people will be very unique. And that nature, both of those things being true about this one entity that we all know, just is really special.
It's just the epitome of a symbol of both something that's in each of our hearts, but that's also represents exploration and reaching.
You're looking at a live view inside Artemis Mission Control here at Johnson Space Center in Houston, Texas. We are currently out of contact with the Artemis II crew. This was a planned, or not really a planned, but a tracked loss of signal that occurs when the crew flies behind the moon. We use the Deep Space Network to communicate with the crew, and when they are behind the moon, they are out of reach of that Deep Space Network. And when you consider our nonstop communications during the time in which we live, this is even more striking. For the Artemis II crew, they're only currently communicating with each other. Now, we expect to regain those communications in under 9 minutes from now, and we also are hopeful for a view of Earthrise. Despite being out of communication, the crew is continuously capturing imagery of their predetermined lunar targets. Now about 7 minutes, 25 seconds until we anticipate regaining communications with the Artemis II crew aboard Orion. In the meantime, Artemis II Lunar Science Deputy Lead Marie Henderson is training trained these astronauts to capture and document their views of the lunar surface for all of us to enjoy back here on Earth.
I cannot wait to hear their voices when they get to the far side of the moon and I can hear them talk about seeing the moon out their window. I try to imagine it now and just tear up thinking about it. Ooh, now I gotta hold on a second. We have human eyeballs connected to wonderfully smart brains our astronaut friends have. They are going to be able to observe the moon in multiple different ways. They can use their eyes, they'll look through their camera and snap pictures, and just looking out the window getting that human experience. But during Apollo, the astronauts were so much closer to the lunar surface. Our astronauts are going to be doing a flyby at a higher altitude, so they're going to be able to see the whole moon as a lunar disk on the lunar far side. That's a brand new, unique perspective that humans haven't been able to look at before. We are doing a lot of lunar geography training with them. They have study sessions and quizzes they can do that are assigned to them. You know, even if you're an astronaut, you still get homework. We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations. There's 4 windows up front. Through one of those windows, one of our astronauts will be using a Nikon D5 camera with an 80 to 400 millimeter lens. So something that allows them to zoom in really far and actually take more detailed observations of the surface. It's almost like looking through a pair of binoculars as well. It's just like being a geologist out in the field. They're telling us what they're seeing, looking for colors, textures, different morphologies, and comparing the region that we're having them look at to the regions that are around them. We have a science team that is planning the targets that are going to be observed, putting them all on the timeline of how they're going to be observed, and then taking the first look at the data when it comes down. The Apollo astronauts were only on the moon for 300 hours total, and they only went to the equator. That's like going to places that were safer landing sites, and they only saw so little, 300 hours total. And so we have so much more to explore and so much more to learn, and we are the beginning of the next generation that gets to start being a part of these discoveries.
We are now 4 minutes and 28 seconds until we expect to regain communications with the astronauts flying aboard Orion on the Artemis II mission. They are now flying behind the moon. While behind the moon at an MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds, we expect this was the point in which they made their closest approach, 4,067 statute miles above the lunar surface. We're live in the Artemis Mission Control Room in Houston, but we are not the only room monitoring today's flyby. As you can see, this is the SIR, the Science Evaluation Room. It's in the same building and just down the hall. It's a multidisciplinary science team supporting the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. You can see the SIR here. That's the Science Evaluation Room. It's embedded within Mission Control to provide science input during live operations like what we see today. But additionally, the Science Mission Operations Room is a back room that processes data, evaluates imagery, and supports rapid analysis. We also have our science officer, Kelsey Young, here on console today. She's serving as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon from Orion's windows. At this time, pilot Victor Glover and mission specialist Christina Cook are observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reed Wiseman and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions. Again, we are standing by to acquire signal from the Orion spacecraft. We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, lunar flyby continues, but Orion has also technically begun its journey home. Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. How many?
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth, we will always choose each other.
Integrity from Earth, our single system, fragile and interconnected, we copy. Those of us that can are looking back.
We are happy to say we copy.
Those first communications back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very, very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home. Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis II. We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis II patches around. We are earthbound and ready to bring you home.
That's great. See the light of day as we head back to